Sorry about that. We had a small technical glitch. So we were just saying that one dimension for the lateral surface of the sac is the height of the cylinder. That would be this length right here, which is 15 inches. And the other is the circumference. That's the distance one time around the circular base of the cylinder. So here's another picture of that stuff sack. To get the lateral area for the stuff sack, that would be 180 pi inches. So how did they get that? Well, the perimeter of the base is actually the circumference of the circle, so that would be 12 pi inches times the height, which is 15 inches. So if we write a formula for calculating the lateral area of a right cylinder in terms of the radius r, the height h, and pi, well, that would be 2 pi rh. Why is that? Because we're multiplying the perimeter of the base, which is the circumference, times the height, which is the 15 inches right here. So now we're going to calculate the total surface area of one of Gino's stuff sacks. So let's work through how they got this. Remember, the total surface area is the lateral surface area plus 2 times the area of the base. Well, we already got that the lateral surface area is 180 pi square inches plus 2 times the area of the base. What did we get for the area of the base? Well, back here we saw that that was 36 pi square inches. So it's going to be plus 2 times 36 pi square inches. So this is how we get that total surface area of 252 pi square inches. So if we want to get a formula for calculating the total surface area of a cylinder in terms of the lateral area and the area of the base, that's going to be the lateral area plus 2 times the area of the base, or we could also write that out as 2 pi rh plus 2 times pi r squared. So to finish off this lesson, we're going to solve 2 problems. The pipe below is open on each end. Chester computes the surface area of the exterior surface of the pipe as 32 pi square feet, whereas Maria computes the surface area as 24 pi square feet. Which student is correct? Well, let's start out by solving the lateral surface area formula. That's going to be 2 times pi times r times h. Well, let's see, 2 times pi times the radius is 2 feet, times the height, which is 6 feet. So once we work all that out, 2 times 2 is 4, 4 times 6 is 24. So that's going to be 24, and then there's a pi left over feet squared. So since it says that the pipe is open on each end, that actually means that we do not need to include the area of the 2 circles. We only need to calculate the lateral surface area. All right, lastly, we're going to solve number 18. A manufacturing company produces plastic cylindrical trash cans with heights of 5 feet and diameters of 2 feet. A 10 feet by 12 feet sheet of plastic is fed into a cutting machine. If each machine cuts the 3 shapes needed to make a trash can, how much scrap plastic is left once the plastic leaves the machine? Show your work. Well, let's first calculate the area of the rectangular piece. So if that's 10 feet by 12 feet, then this area would be 120 feet squared. And they're also saying that we have a cylindrical trash can. So this is just a sketch. This is not going to be a perfect picture. But the reason that it says that we need 3 shapes in order to make this trash can is we need to have a bottom for the trash can. We need to have a curved lateral surface in the middle, but then we don't want the trash to blow away, so we need a top piece to cover the trash can as well. So if the height is 5 feet, and they tell us that the diameter is 2 feet, so then this radius is going to be 1 foot. So let's work out what the total surface area would be. That would be 2 pi RH plus 2 pi r squared. So that's going to be 2 times pi times the radius 1 foot times the height 5 feet plus 2 times pi times the radius 1 foot squared. So if we work this lateral surface area out, 2 times 1 times 5 is 10. It's going to be 10 pi square feet plus 2 times 1 is 2, and there's a pi left over, plus 2 pi feet squared. So in total, that's going to be 12 pi feet squared. But if we get that as a decimal, that's going to be about 37.7 feet squared. So this is a nice multi-step problem because they want to know not just what the area of the rectangular piece is, not just what the surface area of the cylinder is, they want to know how much scrap plastic is left over once the plastic leaves the machine. So that's going to be the total area for the piece that we're using to make the trash can minus the surface area of one trash can. So that's going to be about 82.3 feet squared. All right, that's it for this lesson. The next lesson is going to be over the volume of prisms and cylinders. Thank you for watching.